A dye is injected into the pancreas during a certain medical procedure. A physician injects 0.3 grams of the dye, and a healthy pancreas will secrete 4% of the dye each minute. Predict the amount of dye remaining to the nearest hundredth of a gram in a healthy pancreas 30 minutes after injection. So for this, we are going to use y equals a times b to the x, a basic form of an exponential equation where a is the initial amount and b is the rate of growth or the rate of decay. In this case, y equals a is 0.3, that is the initial amount injected, and it's being secreted at 4%, so that means at 4% per minute, so that means there is 0.96 remaining after each minute, and again, x represents minutes. So if we want to figure out how much is remaining after 30 minutes, y equals 0.3 times 0.96 to the 30th, and that is approximately 0.09 grams. Another example of an exponential function would be dealing with investments. So what is the final amount of a $1,000 investment at 6% annual interest compounded monthly for 10 years? So as soon as we're talking about investments, we want to change our formula. So this is the amount equals the principal amount times 1 plus the interest rate divided by the compounding periods, and then raised to the n times t. So again, P is the principal amount of money we're investing, N is going to be the compounding periods per year, T is going to be how many years. So in this case, we have A equals 1,000 plus 1 plus 0.06, so we have to rate it as a decimal, divided by 12, so that divides our interest rate up by 12 for each month, and then 12 months for 10 years. And you want to plug it directly into your calculator if you can. Be careful on parentheses. And you're approximately going to have $1,819.40 at the end of 10 years.